Good evening, students. Yesterday we have discussed about expected questions from electric charges and field. Today I am going to discuss about expected questions from electrostatic potential and capacitance. So if you like this video, please put like and share to your friends and relatives. Why? Because it is very important for your board exam. Okay, your likes give me more strength to upload more videos. Okay, I will start my session. Electrostatic potential and capacitance. Here the first question. Two charges minus q and plus q are located at points 0, 0, minus a and 0, 0, plus a. Look at the figure. So here two charges, one is minus q, another one plus q, are located along z axis. Minus q is located at 0, 0, minus a and plus q is located at 0, 0, plus a. What is the electrostatic potential at the points 0, 0, z and x, y, 0? So we have to find electrostatic potential due to these two charges at a point 0, 0, z, which is along positive z axis, and another one at a point x, y, 0, that is in xy plane. Okay. Solution. From figure, electrostatic potential U2 plus Q, that is V1, that is KQ by Z minus A. See how we got this Z minus A distance. See from origin to this point Z distance. So remaining this distance from Q to M will be Z minus A. So we got electrostatic potential U2 plus Q at M, that is at 0, 0, z, that is V1 is equal to KQ by Z minus A. Then what about electrostatic potential U2 minus Q, that is V2 is equal to minus KQ by Z plus A. See the distance of this point M from minus Q is Z plus A. So we got V2 is equal to minus KQ by Z plus A. Now electrostatic potential at point M is equal to sum of the individual electric potential, that is V1 plus V2, that is equal to V1 plus we have to substitute KQ by Z minus A plus V2 plus we have to substitute minus KQ by Z plus A. Then KQ I wrote outside, commonly I wrote outside. So inside the bracket there will be 1 by Z minus A minus 1 by Z plus A. So here in the denominator we have Z minus A into Z plus A. So their LCM, that is A minus B into A plus B, A square minus B square, that is Z square minus A square. Okay. So in the numerator we will get Z plus A minus Z plus A. Why? Because minus into minus plus A. So we will get Z plus A minus Z plus A. So here plus Z minus Z cancelled. Plus A 2A. So we got K into Q into 2A by Z square minus A square. So here Q into 2A means electric dipole moment, that is P, by K means 1 by 4 pi epsilon naught into Z square minus A square. So we got electric potential at M due to these two charges. Okay, that is at 0, 0, z along positive z axis. Due to these two charges we got electrostatic potential, that is P by 4 pi epsilon naught Z square minus A square. But what about electrostatic potential due to these two charges at point n, that is at point x comma y comma 0, it will be 0, my dear. Why? Because here this point x comma y comma 0 will be at equal distance from both charges. So then if we add both potential, then we will get 0. Next we will go with second question. A 4 microfarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and it is connected to another uncharged 2 microfarad capacitor. Look at the figure. So here first one capacitor is charged by 200 volt. Then it is disconnected from that 200 volt supply. Later it is connected with another uncharged 2 microfarad capacitor. Okay. How much electrostatic energy of the first capacitor is lost in the form of heat and electromagnetic radiation? So we have to find loss of energy in the first capacitor. Okay. Solution. Initial energy stored. See, initial energy stored in that first capacitor, that is in 4 microfarad, when it is charged by 200 volt, that is U initial is equal to half CV square. So half into C plus, that is 4 microfarad, micro means 10 power minus 6, into V square means 200 whole square, that is equal to 8 into 10 power minus 2 joule. So we got initial energy stored in that first capacitor, that is 8 into 10 power minus 2 joule. Now after connecting this capacitor by disconnecting from the 200 volt supply with the second uncharged capacitor, that is 2 microfarad, there will be a common potential. What is that common potential? That is V common potential is equal to C1 V1 plus C2 V2 by C1 plus C2. So here why C1 plus C2 na, both capacitor connected in parallel. Okay. So common potential means total charge by total capacitance. Total charge means Q1 plus Q2. Q1 means C1 V1 plus Q2 means C2 V2 by total capacitance, that is C1 plus C2. So here C1 means 4 microfarad, that is 4 into 10 power minus 6. V1 means before we charged that 4 microfarad capacitor with 200 volt supply, that is V1. So V1 200 plus C2 means second capacitor, that is 2 microfarad, that is 2 into 10 power minus 6. V2 is 0. Why? Because that is uncharged capacitor. So V2 will be 0 by C1 plus C2, that is 4 into 10 power minus 6 plus 2 into 10 power minus 6. Then if we simplify, we will get 400 by 3 volt. Now final energy. What will be the final energy? That is final energy is equal to half sum of capacitance into square of the common potential. So both capacitors connected in parallel, so we will get C1 plus C2. So half C1 plus C2 common potential square. Then half bracket of C1 C2, they are 4 and 2 microfarad. So I can write 10 power minus 6 commonly outside. Micro means 10 power minus 6. So I wrote 10 power minus 6 commonly outside. Inside the bracket there will be 4 and 2 into VC square means VC we got 400 by 3, that is 400 by 3 whole square. Then we will get 5.33 into 10 power minus 2 joule. Okay. Now what is the loss in energy in first capacitor? That is change in energy is equal to initial energy minus final energy. So initial energy we got 8 into 10 power minus 2 joule minus final energy we got 5.33 into 10 power minus 2 joule. So if we subtract, that means 10 power minus 2 I wrote commonly outside. Inside the bracket there will be 8 minus 5.33. Then we will get 2.67 joule. So we got loss in energy in first capacitor, that is 2.67 joule. So this problem is very very important, my dear students. Okay, now I will go with third question. Here the third question. Two charged conducting spheres of radii A and B are connected to each other by a wire. Look at the figure. So two charged conducting spheres, okay, radii A and B are connected to each other by a wire, okay. What is the ratio of electric fields at the surfaces of the two spheres? So we have to find ratio of electric fields at the surfaces of the two spheres after they connected with a conducting wire, okay. Next, use the result obtained to explain why charge density on the sharp and pointed ends of a conductor is higher than that on its flatter portions. So by using this result, we have to explain why charge density resides more on pointed ends and sharp ends other than flatter portions. Okay. Solution. See, charges will flow between two spheres until potential will be equal. After potential equal means charge won't flow from one sphere to another sphere. So we can say when V1 equal to V2, then there will be no flow of charge from sphere 1 to sphere 2. Okay. So that implies V1 means Q1 by C1, V2 means Q2 by C2. So from this we can write Q1 by Q2 is equal to C1 by C2. But C1 by C2 means capacitance of this sphere, conducting sphere, that is 4 pi epsilon naught into radius, that is A, by C2 means 4 pi epsilon naught into radius, that is B, that is equal to 4 pi epsilon naught cancel, then we will get A by B. So in the above Q1 by Q2, in the place of C1 by C2, we can write A by B. So above equation, we will get Q1 by Q2 is equal to A by B. So here we have to calculate ratio of electric field, that is E1 by E2 is equal to, E1 means you know that KQ1 by A square, E2 means you know that KQ2 by B square. So K cancelled, then we will get Q1 by Q2 into B square by A square. So here Q1 by Q2 means A by B into B square by A square. So we got ratio of electric fields, that is B by A. So ratio of electric fields we got in these two spheres, that is B by A. So first question completed. Now second question, we have to explain why this charge density is more on sharp and pointed ends other than flatter portions. Okay, for that, see, we know that E1 by E2 is equal to sigma 1 by sigma 2. But even by E2 we got B by A, so we can write sigma 1 by sigma 2 is equal to B by A. That means here sigma 1 by sigma 2 is equal to B by A means that is surface charge density is inversely proportional to the radius of the sphere. That means if radius is more, surface charge density is less. So that's why on flatter portions surface charge density is less than compared to sharp and pointed ends. Okay, so that's about this session, my dear students. In next session I will upload chapter 3, that is current electricity. So next session I will upload expected questions from current electricity. Please, if you like it, please put like, my dear students. If you put like, that will give more strength to me to upload more videos. Okay, so please put like, share to your friends and relatives. These are very very important questions. These are expected questions in upcoming physics board exam. Okay, so please share it, please like it, share it and subscribe it, and don't forget to put like, my dear student. Okay, bye students.